Okay, so Chad is writing that he's in the call.
Okay. Oh, yeah. Okay.
Hey, Thomas. Nice
Hello.
to see you.
Hello, Italy.
Nice. Still waiting for Chad. Oh, yeah. Here he is. Hi, Chad.
Yeah. Okay, guys, you're online. Have a great discussion.
Thanks.
Oh, great. Thank you. So let me introduce today's panelists and also the topic of discussion. So let's start with Thomas Wolfe, who is...
Okay, guys, you're online.
Yeah, thank you. So Thomas is Chief Science Officer of Hugging Face, and he's doing he and his company doing a lot of work to democratize NLP for different parties, and he has a background in quantum physics and also in law, which is pretty amazing. Yeah. So other expert is Vitaly Radchenko, who is a data scientist in USCAN, and he has an interest in NLP, and he has a lot of projects done in USCAN, which is a company that indexes the social media and provides some insights to businesses. And he also leads a lot of courses and meetups. Yeah, so that's Vitaly. And also, let me introduce Chad Mills, who is a manager for Grammarly Applied Research, and he leads applied and machine learning, engineering, and computational linguistics teams in North America. So that's the SF and Vancouver offices of Grammarly and New York office. And he has a lot of experience in this domain. He spent like 10 years in Microsoft, evolving the field and moving it forward. He has a PhD in computational linguistics, and also, different companies where he worked on NLP projects. So, welcome our experts. And the topic of discussion is democratization of NLP, and especially what it means for the building a product for the industry. And like I just dropped some context. Like for me, it was I dived into transformers not so like recently, maybe a year ago, and when I went through all the papers and overview videos, they are like overwhelming. A lots of research is done in this field by different labs, and I don't know. So it's a very wide field, and I thought, all right, I have to implement something. And I thought that I have to spend like 2 months doing something. And then I come to Hugging Face site, and there's like almost every model just listed there. You just take like 3 lines of code and it's working. And like not only working, you can like dig into how it's done inside and like very easily tweak, like do anything with attention heads, with like prune something and doing that's very easily. And I was very fascinated by that. And that is like, for me, a big sign that actually doing NLP is much more accessible now than it was maybe 2 years before. Thanks Hugging Face for that partially. And I think like different like efforts in community also led to that. So maybe let's discuss this change. And yeah, so I have like general questions, a question to all the experts. So yeah, and also very important announcement. So in the spirit of this democratization, please everybody who is on the conference, please join the Zoom call. Be careful to like mute the background sounds until you like want to really ask something, but please welcome to join. And yeah, let's have a democratic talk, and I will start it. And yeah, so first question to all the experts: what do you think are latest, like one or two things that like fascinate you and that move the field in this direction, in like making it accessible for everyone? So maybe Thomas, could you start?
Yeah, sure. So you've probably seen something that's really, really important for me. It actually dates back to my PhD time when I was doing PhD on low temperature physics. I was using a lot of Soviets research at that time, and that was very hard to get through because it was done before the before the internet, also before everything was translated and things like that, and also everything was behind paywall. Nothing like that, publication, thing like that. So when I reached actually the AI field, like 6 years ago now, I was amazed already that everything was posted on archive, and I was like, wow, this is so much better. But then I also saw all this code that was actually very hard to reuse and very hard to access, and kind of required you to be a deep learning researcher to be able to use it, while it could have been used by everybody. So I kind of started to push these things. So this is something, this is really, really important for me, making this accessible. And I think it's better for everyone because then you can develop new models on top of this really quickly. You don't spend time doing what other people have done, but you spend time doing what you want to do for your application. You spend time like understand how it's good to, how you should fine tune your model for your own application, and not how you should reproduce the thing that people have done. So it's really the way we're going forward. I think for the models, and now we want to do that for the data set as well, and just maybe apply this thing. I mean, if there is another AI winter and we lose maybe something, I think one very big advancement that we will have made is this open source kind of philosophy, open source mindset in the AI community. And I think this is just maybe the biggest thing that has happened in the current AI summer, I think.
Yeah, totally agree. So like, if you have less budget for the research, you can like reuse much more easily and don't spend like months on producing something. Oh, yeah, thank you. So Vitaly, could you share your thoughts?
Yes.
Please.
One?
Could you please share your top one thing?
Okay. I talked about that. I totally agree with Thomas that the most important thing that that recent times we all like all companies, all like new implementations are open sourced, and they are like shared with the community. And then the main like win for the industry, because last years, I think 2 years ago, 3 years ago, it was like only internal some researchers, and they were shared. For example, even in competitions, we saw like always the same solutions where it was like a small improvements with their solutions. But recent years, when like the transformers came out, Hugging Face, they're like RPS for this democratization. Many people want to like support this this mindset. They want to like help with such open source, because they see like example of Hugging Face, and so they want to like follow it and make their own like help to the whole community. I think it's like a little bit a change of mindset of such internal researchers, and people want to share their internal research to public and help others.
Yeah, so like you also see like lots of things being open source, like moves the thing forward.
Yes, even on my own example, we always try to think about sharing our knowledge. Maybe we will talk on a conference about it, or just share our results, share models, share some experience. I don't know, maybe some technical articles on our company blog or on some other like platform. But it's very nice when you can share knowledge and maybe um, use the best solutions and don't repeat the same like obstacles to tackle with the same obstacles when other have done before us, so we can be more like efficient in our researches or even applying some things in our product.
Thank you. Chad, would you highlight some like top 1 or 2 things in this topic?
Sure. So first, I definitely agree with kind of the community aspects of this and tooling, like all the way up the stack from AWS, making it easier to like scale things to, you know, the standardization around PyTorch to kind of Hugging Face, making it super easy. So I definitely love the like that whole side of things, but maybe to focus on something a little bit different. I think something that's been really interesting to me is this whole kind of like subfield of Bertology. So as we've been moving more and more in this direction of, you know, these black box models, every time a researcher adds one of these components, like whether it was convolution or whether it was, I don't know, like attention, like there's always some motivation and some inspiration for why that happens. It's not random. But as these things get more and more complex, it's just really hard to understand what's actually going on. And I love that they've, I guess researchers have been kind of probing these models and understanding like what makes them tick. And, you know, like I think in that original Bertology paper, things like the model seems to recover syntactic information, but it might not actually use it. And there's some semantic information that it's figuring out. But again, it might not actually be using that. Like that might be an artifact, and just kind of teasing out the causality and the areas where these models struggle, like, for example, negation and scope type stuff. So I love that we're starting to kind of peel back the black box, and I don't think that likely ever would have happened unless it had kind of spread to the point where these technologies were so widely used, and you know, you could have a large enough community that you could invest time in just kind of digging deeper and understanding them. So that's one of my favorite developments, because I think that'll really help us move forward, kind of even beyond this current wave.
Yeah, so like being if like BERT would not be so widespread, then the whole community would not be so concentrated on like piling up this, like looking into this particular architecture, like transformers. So it somehow happened like by itself. So like everybody started focusing on that and stopped doing LSTMs. Maybe somebody has like real strong opinion. Why did it happen?
Why did we stop using LSTM, you mean?
Yeah, so why is BERT become like so ubiquitous?
Yeah, I think that's I think it's also good maybe not to over focus on transformer. Maybe there is too much of a focus right now, but yeah, I mean, maybe there was also too much of a focus on LSTM. There was definitely some research on LSTM that was really overfitting on the architecture itself and trying to understand some stuff that was just artifact. But there've been people training large scale LSTM, but it was just much more harder basically. There was this, I think that like the sentiment neuron, you know, the first large scale Allegrat for the training on Amazon Review was probably the largest. There was also the billion word language model. Yeah, that was from Google. But yeah, but basically transformers seems to work better for a few things, and that are kind of important apparently. There is not enough, I think, paper comparing LSTM and transformers architecture and trying to understand what are the different inductive bias. There's one I like to cite from Amsterdam University from UK who investigate how they both behave when you look at compositionality, when you look at how the model kind of tease the mix these words together to build a sentence to build the meaning, inside the sentences. And they kind of show that transformers perform better on a few metrics. But there's also results that show that LSTM are better for simple text classification. ULM fit is a very strong baseline for just text classification. So I think we still don't really understand what are the exact inductive bias of the one and the other. And sometimes it's a little bit of a ideology battle. I think like people have been working on LSTM for so long, so they are like, no, I don't want to touch transformer. I think the LSTM are better. And the other, like people who like new stuff are like, no, transformer are better. I don't want to touch LSTM. So yeah, maybe in the future we can have like a more peaceful research on this and just say, okay, these are just two architecture. There is no specific ideology behind them. Just let's try to compare them together. But at the moment, yeah, transformer are clearly the most widely used architecture for large-scale training. So we kind of became against our will, like advocate for transformer. Well, I don't really feel so strongly about this architecture. I like them, but yeah. One thing I like is that they're very simple to write and they're also very simple to explain. When you write the math, it's actually just a lot simpler to write than LSTM. So they are simpler to teach when you do teaching. Yeah. But you probably have better ideas. You've like Chad and Vitaly, you've been there longer than me, so I guess you know more of the background is.
I would like to add to Thomas, yes, about like compared LSTM transformer. No, from the applied way, yes, when we talking about applying it in a product, we always look on some benchmarks, on some public results, and then we compare in such way different architectures, different improvements, and we discussing to try or not to try some new stuff. So when we see when Bird improves on blue benchmark on all tasks, we don't have any chance to not to try this new architecture, because if it works for, I don't know, in glue the 9 tasks and it outperforms previous results with just simple fine tuning, we should of course try it, and with obvious reasons. So just talking about comparing complexity of training BERT and LSTM, I could say that LSTM is harder to train because, for example, for transformers, we have many pre-trained models, and it the tokenizer model, it has its vocabulary, it's trained on public corpus, on a big corpus, and weights, of course. In LSTM, for training LSTM, we need find what the embeddings. We should find the same tokenizer which what the embeddings were trained. So we should handle somehow out of vocabulary words. If, for example, water to work or glove, yes. For example, for fast text, of course, we can handle all words, but for example, forward to back and glove, we can't. So there's some problems, and LSTM, I can't say that it's powerful model, but it has few weights. I can say that many weights in LSTM, but when we add more weights, it starts to overfit. So we should find optimized number of weights, and it's more complex. But now in transformers, I think for me it's much easier. I don't know how to say, but transformers for me, with no it is easy to me to come to the transformers and apply it for all of our tasks, and we have a big gain for our accuracy, for different tasks, for classification tasks, so for token classification, and so on.
Thank you, Vitaly. From what I hear is a big impact of Hugging Face transformers library to make it easier. Like a big factor why you would like apply to your problems the transformers, because it just works.
To start, yes, it is to start from the first view.
You think we should have some LSTM as well?
No, I don't think.
I was wondering, we could add DeepMoji was a nice LSTM for sentiment detection. I was wondering maybe we would add it at some point. But yeah.
Chad, what do you think?
I mean, I think I've worked at different companies that have different, portfolios of models and algorithms they use. And I'll say that, like, I love transformers. They're amazing. There's also, a time for like logistic regression. There's a time for fast text. There's like, depending on the scale of data you have and how, document classification, for example, with a fixed text window can be a challenge. So there's just like lots of different reasons to try these different approaches. And certainly transformers are, just like dominating all of the benchmarks in a lot of the top tasks. But yeah, I would say, like, I don't know, at least my personal use of this technology and kind of what I've observed has often been a trade-off between like simplicity and complexity. And certainly the tools are making things like transformers much easier than ever. And there's still the trade-offs between like performance and scalability and that sort of thing, as well as some of these like more model-specific trade-offs between like, are you classifying many different categories, or are you at like a sentence level where a fixed window is no problem? And there are all these constraints for every modeling approach you take. So I definitely think you need a portfolio, and I'm really excited about transformers, like obviously the impact they're having, and LSTMs are great too, and there's a place for them. So yeah, I wouldn't exclude a particular approach. I think we can include all of them.
Thank you. All right, so like now for something completely different. So I have like a question. Maybe it relates to every expert here. So I will start with Thomas. So question. I would imagine that, like, maybe from my experience or just in general, like doing moving some research forward, you need a lot of engineering effort, and also you should like spend a lot of time like doing like scientific work, doing experiments, planning experiments. And how would you like describe the ratio? What kind of like, how much of engineering do you do to like do some of research that you do at Hugging Face, and how many like more this pure research thing?
Yeah, so I think at Hugging Face, Hugging Face is about 20 people right now, so it's quite a small team, I think. So there is a culture of doing the stuff yourself, basically. I think most of the library we do, they are coded by just a few people. But I think it's quite different, yeah, as you say. So we have decided to connect strongly open source to research. So usually when we do research, it's made to be open source. And when we do open source, it's usually on like kind of recent research project, or like state-of-the-art or barely open source research project that we try to make more accessible. So the two are very connected. But the people who do pure research in our team, there is like maybe 4 people that are mostly led now by Sasha Rush, who is a professor at Cornell Tech as well, at Hugging Face. They do some engineering, but not so much. I think they use usually standard tool like PyTorch is pretty much a nice toolbox for a lot of things. They do, some of them works, the one who works on like sparsity, for instance, they do very strong engineering because sparsity is very hard to make efficient on GPU, basically just not efficient at the moment. So we also plan to open source probably one more library on this that would make sparsity more efficient on GPU for the usual PyTorch TensorFlow kind of thing.
Oh, nice.
Mostly for PyTorch, because I think TensorFlow you can already do pretty cool stuff. So these people work a lot on strong engineering, but the other one who work, for instance, on more like Bertology paper, that's something we find very interesting as well. They use standard tools, so they usually don't dive a lot in engineering. But on the other hand of the spectrum, when you open source this and you want it to be efficient and you want kind of to look forward at the research how to like remove the burden of some of the burden from the researcher about this. I'm thinking about, for instance, very large data sets, or this is something I've been working a lot recently. How can you like train your model on 10, 20 gigabytes of text without all the pain points that are there right now? There's a lot of pain points, I think, and it could be a lot more easier. So here it's mostly an engineering thing, but here we're more doing stuff like the people who develop PyTorch TensorFlow. We try to enable like future stuff. I mean, before PyTorch, you could already write, your backward propagation thing in NumPy. That's definitely possible. That's something you can do, and people have been doing that. Or you could write your own CUDA kernel, as it was done in the beginning. But just by making a strong engineering effort, you can make this kind of very easy to do, and then people start to concentrate on other stuff, and that's when the research becomes interesting again, right? Yeah. So this for us is usually, it's such an effort in terms of engineering that it's hard to do research at the same time, I think. Like in the beginning of neural network, like the two were tied. If you wanted to try to train a large neural net, you had to develop your own CUDA kernel for backpropagation. So you had to do both. But now we have so many tools already there that you can do a lot of research without having to dive too much in the engineering, I think. So in our team, mostly the researchers don't dive too much in engineering. Yeah, it's pretty separate.
So if you would just abstractly quantify the amount of research and engineering that you do as a company, what that proportion would be?
We are very uncommon company, I think. So I don't know how much you can generalize that.
For you, right?
Oh, for me, yeah, it's usually big chunk. So right now I do a lot of open source. I do it's usually half, I would say, but I'd usually do form of science and then form of open source. I'm bad at multitasking, so I try to avoid that. So yeah, I spend. So right now it's not about open sourcing at the moment.
And for the Hugging Face as a company?
I would say maybe 1/3 is doing science, and then 2/3 are doing more engineering, open source, and everything that goes around this.
And maybe a follow-up question. Do people differ that do this 1/3 of engineering and 2/3 of research? From what I hear, the culture is so that you do everything by yourself. If you need some engineering, you do that, and then you do some research based on that. Or are these profiles different?
Oh yeah, so the fact that we are very small means that everybody is super autonomous in the company. So the people mostly do what they want to do. So they're usually in charge of a huge part of the thing, and they do basically what they want. So when they want to do some science, they do a science project. They say, okay, I want to do this science project. I'll do that. And then often after a science project, people are a little bit tired. Science is kind of tough, I think. Often it doesn't work, so it's painful. And then they want to do something that is more maybe rewarding, and open sourcing something is quite rewarding. I think the community is happy. So people move from one to the other, and we have these people in charge of big things. So for instance, Victor San is in charge of all the pruning efficiency, but that's his own field. He wanted to start working on that, and he's done really awesome work on that. Patrick is very fascinated by sparse model like reformer and longformer. So right now he's working a lot on that. Yeah, so it's very, very free. and we usually decide on whether we want to work on a project together. We talk and we're like, okay, the only metrics for us is how impactful it can be for the community. If something is not impactful enough, we just say, okay, maybe it's not worth spending time on it, but if something looks important for the community, then we say, okay, let's go, let's do something on that.
Fascinating. Yeah, so let's hear more examples from other companies. Vitaly, could you share like your setting? Like, let's focus on only the ML part of. I know you have like various data pipelines and like infrastructure part, but if we say like about really bringing ML features to production, so like only this part.
Yeah, I understand, but we can't also divide it because like they should follow each other. But I can say that I don't do much research because as a product company and it's a not big product company, we can't allow to us to make just research for research, just for research. So we need to understand why we should do it and should we do it. So as for me, I think I spend on research maybe 10% of my time or maybe even less, because I can say how it happens. For example, when Hugging Face announces some new stuff, some new feature which they implement, I think if we can apply it to our pipeline, for example, to improve our pipeline or to improve our accuracy or some other stuff, I don't know, it could be with accuracy or performance, doesn't matter, and we try it on our data, on our task, and if it works great, we will apply it on all of our features which we have. So of course, if we have ideas, we can try them, but it happens really rare. So I can say that we like our main focus on deliver features to our clients and make them happy and bring them new value to, for example, work with our data more efficiently.
Could you maybe say something about if you have some new feature that you like didn't develop before and you like start developing it, you still need some like research what like approaches work and what not, and it still like maybe takes some time?
For this time, I think it's really a rare case because, for example, like many tasks I can classify on to text classification, token classification, question answering, I don't know, compare two sentences, or comparing sentences or something like this. So we have like a bunch of tasks which we can, for example, find solutions in open source, for example, on glue benchmark or super glue benchmark, and we understand which approach work better. So we don't like spend months for trying different approaches. We just like try maybe 2 or 3 which like on the leaderboard higher, and we like comparing them and choose the most accurate and efficient, like something like this.
I see.
So we just we don't have like many complicated tasks. It's most of our tasks are like standard tasks, which are maybe similar, and only domain area depends, or maybe some motivation depends. But like on like architecture stuff, or like some formulation of this task are almost the same. So it's easier in our case.
So in your case, like if you like would take the same task like 2 or 3 years ago, is it like currently easier to do? Like some new feature?
For example, if we like did decide that we need some new text classification feature, and we, for example, have the data somewhere, we can like move to the project with this feature maybe in 2 or 3 days. So, so we have like our custom pipeline where we integrate some transformer model which we want, and we have like many optimization stuff in it. So they are like generalized, and we can apply this easier to the new feature, and it will be in fast way anyway in production. So the main like problem for us is to label the data, to find this data, to label it. Yeah, because we have like many clients from different domains. They could be, for example, from banks, retailers, airline companies, so on. So from different areas, and the problem is to suit our model to all these domains to make our models work perfectly on all domains. And this is the main problem. So we need to like collect data from these domains, relabel it, and try on all these domains to like prove that we work great on all these domains. So this like we have more product problems than implementation problems.
I see. Thank you. Chad, could you share some of your context on what is the ratio of research and engineering, and probably how did it change? Maybe you have like overview from more longer timeline, so, and compare it with like recent maybe year, if it's easier or not currently do things.
Yeah, well, I'll answer that. That later question is definitely easier. So I'll start with that, which is that it's definitely easier. It's much easier today than it was, long ago. Maybe I can paint the picture of kind of some of my experience here. So I started out maybe about 15 years ago, IC, beginning of my career, and kind of in that sort of time period, I think it was mostly only the really big tech companies that were in this space. I mean, not just NLP, I mean like machine learning, this whole field that we're in, a little conceived a little more broadly. And, you might have a research lab like Microsoft Research, or, Google hired a bunch of researchers that were, I think, a little more hands-on with the product. But I actually started at Microsoft at this company, or on this team that was formed by Microsoft Research, and they were trying to figure out how to productize it and like make it real. And we didn't really have people with these titles at the time, like that didn't exist. And kind of that's around the time that, I mean, I don't know, maybe like 4 or 5 years in the future, like data science became like a big thing. And so I think it was maybe the early wave of that. And as our team grew over time, the way we had to hire people with this skill set was, it was really, if we hired people that had like machine learning PhDs, that could work, but they tended to be purely academic and like not as into the, kind of challenges of actually productizing and scaling. We ended up actually having the most success hiring people from a bunch of different fields. So like Thomas, I was interested in your background. I've worked with like PhDs in physics, PhDs in psychology, like more on the experimental side, economics, like just, it's almost like kind of at the beginning of the computing industry, what you read about. I mean, I wasn't there, but where it's just like people who are smart, who kind of like understand reading literature and have this real desire, like oftentimes they've like picked up the CS type skills along the way. And I think at that time it was more like generalists. Like you really needed people who could understand the literature and the performance constraints and the whole field of like data science that emerged. I think it was a very general one. So I mean, I think if you look at Microsoft or Uber today, they both conceive of data science in this really broad sense where you have generalists. And then companies like Facebook, Google, Amazon, they tend to really specialize. And not only do they have this distinction between researchers and engineers or machine learning engineers, they'll also have like researchers that work on platformy things, researchers that are more academic oriented, researchers that are like embedded with a product team, researchers that incubate some new project at the company. And so like there are all these different like ways to divide the skill set. So I'm not sure actually that the notion of ratios is something that I would really look at, because the nuance of what these different roles are doing is very different. So at Grammarly, for example, we have interface teams. Like, so we have a team around our Chrome extension, and we have a team around our Office add-in and our iOS keyboard. And so at another company, the interface engineers might be embedded as part of the broader team that's doing it. And, you know, you also have backend infrastructure working hand in hand. Like, so for example, Facebook is more like that. You have everyone together on a team building an end-to-end feature. So when we think about ratios of like ML engineers to researchers or engineers to researchers, you really have to be careful about what that scope is. Just to give like a more concrete number, I think at Grammarly, it's probably something like, I don't know, maybe 1-to-1 overall in terms of like research and ML engineering specifically. Like broader engineering is much more than that, including like interface and all that stuff. But even if you look at our Kyiv versus our US offices, it's very different. So in Kyiv, I think the researchers tend to be more engineering oriented, and there's more of them relative to ML engineers. And in the US, the researchers tend to be a little bit more academic, and we have more engineers relative to researchers. So I think it's really hard to like suss out like what's the right ratio. I think the simple version of this is that everyone divides the space of skill sets differently. And you can even have some companies where there's someone who's amazing in this area, but their skill set isn't quite aligned to the way that the roles break down. And that can be really unfortunate. But I guess like as you're building a system, you kind of organically evolve the needs of your team, the skill sets you find, and, you know, hopefully you don't find yourself backed into a corner where you have to make like some big change in the skill sets. But I think these things organically evolve based on the maturity of the product, the maturity of your infrastructure, the types of problems you're solving. And I don't think there's like a general blanket right answer for this.
Thank you. That was a very broad answer. And do you think, so you said that it become easier to do things. And do you think like requirements for those roles changed?
Yeah, dramatically. So maybe just to the first time I was hiring, for example, it took about 18 months to find someone to like, Microsoft formed a team around two of us that just like happened to have the skill set. Like I was on an internship, this other guy was like a contractor actually initially, and they like formed a data team around us. And it took us 18 months to hire someone, and we didn't know how to find them. And I think we sped it up to maybe like 6 months after a couple years like of this. And then, you know, now it's gotten to the point where there are people with like undergraduate degrees in something very relevant, or they've like published papers in the research community. It's not as specialized. And so that's broadened the skill set. And, you know, as the community gets bigger, that also fosters the ability for, you know, companies like Hugging Face, where, you know, now there's so many people doing this that you can actually make a living based off of tools. You don't need everything to be custom built for a given implementation at one of the biggest tech companies in the world. Now everyone can, you know, just use some reusable AWS infrastructure and, you know, some specialized tools on top of that. And, or you know, like there are other clouds out there, but you know, like the tooling, the experience, the way that it's taught in schools, like you can get master's degrees that are focused on like computational linguistics or data science. So like if you want to specialize more, you don't have to go to a PhD anymore. Yeah, so I would just say that I think certainly in the spirit of talking about democratizing these things, I think the ease with which things are done has made it so that you don't need as much experience. You also don't need people that are like these unicorns that are like, you have to wait 18 months for them to come along, just because there are so many things they have to know. They have to know about experimentation, statistics, they have to know about machine learning, they have to know about like computer science and architecture and scaling systems. And like, you don't have to find these people anywhere. Now there's enough knowledge that's widely enough distributed that you can take experts, and there are like ways that you can get them to work together effectively.
Oh, I think that's dramatic, like 18 months and what we currently have. I have a next question to Thomas. So we are talking a lot about transformers and a Hugging Face, and I have this. I did like very small research on like the company, what it does. So I installed the chatbot that like talking egg, and also there is a talking dog. Talking egg didn't work on my phone, but Hugging Face chatbot did work, and I like chatted a bit with it. And so the question is like having these things available, like libraries and data sets and pre-trained models, it's like super cool. We've already like there was a previous talk that Thomas gave about that, and it's super incredible. So apart from like doing the open source things and like being a hub and like being librarian for these pre-trained models and developing these open source tools, what is the focus of Hugging Face as a company?
Yeah, okay, that's a good question. So the chatbot app is now really not really maintained anymore. We should probably stop it, because maybe one day it will say stupid stuff and people will be, oh, that's that's what we started to do in the beginning. We were doing a game that was kind of like the Tamagotchi. How would the Tamagotchi would be if you were to build them in the era of deep learning? They would be very interactive, a lot more creative. So it was really nice. But while we were developing this app, that's also when we started to open source this internal tool we had. So the first one was this implementation of GPT-1. That was the first kind of large scale transformer. And then this actually got up so much traction that just nobody was working on the app anymore. So we don't really work on that anymore. I think we stopped a lot of them. There's probably a few that are still working. The Talking Head, you can install the app, so probably you can still use it. But we don't do the chatbots anymore. Now I think we really have this core value of doing this this community, this open source, this open sharing mix of science and community. And so we want to find we want to find a business model that fits with this. That's very important for us. I think we want to keep our DNA. I think that's what's defined us as a company. And now a lot of people who have joined the company recently, they really believe into that. I think it's part of the mission. It's kind of a mission. It has become a mission company. And I feel very good about that. So we are more looking at things like GitHub, which is now synonym for open source, but which is still a company and that actually makes money. Well, they don't need to now because they're part of Microsoft, but we think we want to find a way to have a model that fits as well, that allow us to keep doing what we like to do. So probably like specific services for enterprises, basically. We want to keep it free for researchers because most of the researchers, they don't have a deep pockets. So we want to keep this free, and we think it's very important because that's what interests us with the research as well. We want to keep that, but something that they are not really useful for researcher. Like when you want very fast inference, you have like latency constraint. That's not really a researcher problem, for instance. So these are things that people could pay off, and basically there are a lot of things that you could make. So last year we raised some money, which give us actually quite a lot of time before we really need to have an important stream of revenue. So we have time to kind of experiment, to brainstorm around what would make sense for the company. So we've started to do some stuff this summer. We started to have an API, so you can access the model, all the models that are in the hub, you can access them for free on the internet. But if you want to access with a lot of data, if you have to have a requirement which is not we made this so people can actually experiment with the model. It's the same idea of bias ethics. You want to be able to try some stuff with the model, to play with them, to understand the limits of this model. So we think it's fair. But once you use them with a very, like a lot of data, probably you're not really experimenting anymore and you're just actually powering something. So then you can start to have like some revenue past this. So this is the kind of idea we're playing with right now. Something that would make sense. I think there's a lot of room for things to do. There's a lot of good example of like also open core community like Mongo, also community around all the open source kernel like Linux, Red Hat, things like that. I think there's a lot of things you can do, and that's what excites us the most right now in terms of more like business focus, I would say.
So if you would like from just your personal opinion, if you can share that. How would you see like Hugging Face in maybe like 3 years? So that's a core open source core thing, and like number of like paid services, and so you're trying to find business model like that.
Yeah, that's one possible option. Yeah, we have been redefining Hugging Face a lot in the beginning. I think it started. My initial goal that was kind of ambitious was starting to make a little deep mine of NLP. I still think it would be quite nice to do that. But in the meantime, while we were doing that, we kind of discovered all the power of having this huge community. And now I'm actually much more excited about that than the actually kind of closed model of DeepMind or OpenAI. I think it's much more exciting to see people being like, oh yeah, I want to contribute a new model myself also. Oh, and I found a bug in this in this new span-BERT implementation. I find this much more rewarding actually than just having your closed code in your own company.
Yeah, fascinating.
So we keep redefining the mission, the goals, of the company, but mostly to increase it. I think just more open and more open. So I don't know how we will look in 3 years, but if it could be with a bigger community, that would be better, in my opinion.
Did you think about something like paid API access, something like GPT-3, I think will become? Just random question.
Yeah, GPT-3. I mean, a lot of people are talking about it. I haven't really read the paper yet, I must say. This is not super exciting to me, mostly because it's against a lot of things I'm for. Like, I think it's a model that's just no normal people can run on his own computer. It's a model that you cannot investigate. It's a model that you cannot access. So it's really outside of my current target. But I still think it's interesting. If there was like some people are trying to like train an open GPT-3, and we would be happy to welcome it in the library. But yeah, this kind of paid API, if there was also a public way to access GPT-3 and to really try to understand what's happening inside, try to do some Bertology on GPT-3, that would be exciting. I would like to see that. And if we could do that, I would be really happy for us to do that. And then if people want to use it, then yeah, a paid API makes sense, I think. But the paid API only is very frustrating, I think.
I see.
My opinion.
All right. So let me see if we have some questions from the auditorium. Oh. So all the people who have joined, please feel free to, if you're shy, to raise a hand, and I will like ask you directly, or just jump in and try to talk something, and we will hear you. Yeah. So having said that, I have like one concluding question. Maybe we can like discuss that a bit here. So what like things are still not there, like for NLP to really be like much more accessible to everyone? So maybe the last question was to Thomas. Maybe Vitaly, could you go on this one?
I don't know what to say. I think it's everyone could do some stuff with NLP now, because we need just a GPU and to install Hugging Face from Pipe. So I don't know what's the problem now, but I think I don't know what to say, because now we should not we, of course, but maybe researchers or some even big industry companies should concentrate maybe on increasing performance, like speed up, maybe make smaller models with the same accuracy. So we have some areas for research more. As Chet said on the first question, he said that, for example, in biotology, what is good, that there are many areas to research more. And for example, if we see like the progress, yes, for example, from Bird to Roberta, yes, from Roberta to Electra, and so on, in each model, each new model, authors try to improve some decent area. For example, in Roberta, they removed laws. In Electra, they make the shared weights and so on. So we are going to the future with open areas where we can do more research, and there is a way to improve model performance, to make it more, for example, scalable, faster, and even better in accuracy. For example, if we find some new laws, maybe some other, some improved attention. I don't know. It's like just my thoughts, but it's great that we have such areas for improvement instead of, for example, LSTM, which are presented on research space maybe from 1991, I think. So it's a new area, and we have a big horizons for this.
So from what I hear, you are happy with current tools?
Yes, of course. I'm happy. I think, of course, we can work on
things.
For example, yeah. For example, in our company, if we speak about our product, we just work on improving performance model, because like accuracy, we satisfied with the accuracy, but we try to improve the performance. So we try some distillation, we try some batch optimization, and so on. So we on our product, we work on increasing performance. So I think for us, for example, if you say about me, yes, I would like to see some maybe new researches and improvements on model performance, so we can save money on. We can save money and, for example, provide our service cheaper, or we can scale it to more data.
Yeah, I think I totally share this consideration that models might be too big for the task that they solve. Maybe some work has to be done to make them much more efficient.
Yeah, for example, recent works on quantization or pruning, I think, and there was a research. Maybe then even bird model that doesn't need. I think a half of weights that doesn't do anything on this model. So we have a plenty of areas for research and to optimize and make architectures more efficient.
So performance, that's one, right? Thomas, would you add something?
Yeah, performance is very important. I agree. Yeah. For one, what I'm interested right now is to try to connect more the models to their training data set. When your model is failing, or when your model does a bad prediction, or a gender bias prediction, or something you would like to change, it would be very nice to be able to actually connect that with the training data points that actually made the model doing this badly. There are other things on the training data set, obviously, but this is already a huge factor. And so that's something we would like to push to make this connection, to not just ship the model as an artifact, but to be able to kind of understand the model as a training process. And I think this will be helpful for researcher to understand how to make this model better, but also for practitioner to be able to do some interpretability and like giving reason for the model decision. So yeah, that's something we are working on. I think it's missing. I think there is just no way to do that right now in a way that is, well, that's just one data point. There are many things we're working on, but that's something I haven't talked about. I think that's something.
And by connecting, you mean like having some understanding of like training distribution and the model distribution and like having some insights, or you mean something different?
Yeah, there are many aspects. So this aspect is one important one, which is kind of an open research question at the moment. How can you say, for instance, also when you're out of the training distribution, that's something that is important right now. It's very hard to say that. And I don't think we really know how to do that, but I also don't think there is enough people kind of studying that. Maybe because I think the tools are lacking on the dataset side. That's why I've been spending a lot of time and energy on dataset sides right now. Trying to make
and how would you imagine that dataset tool that you're talking about? What it would provide?
It should provide like very fast and simple access to the training data points that you want to look for. Yeah, so this is like a way to basically, you can do right now some stuff if you like build an index with Elasticsearch on top of a training data set, but that's something that you really have to homemade yourself, and it's kind of really hard to do, and it's still kind of a research project. I think this could be streamlined in a standard tool that people could use to understand the model decision better. Still quite blurry because that's definitely something that is also a current active research direction. I think interpretability, nobody really know how to do it right now, right? Some people have been studying attention. I think there is also people say, okay, but not everything is there, or maybe it's also not just a cause of the behavior of the model, but just like a byproduct or like a side effect. So it's still very open, but I think this is very important at the same time for research and for people who use this model to be able to understand when and why they fail. It's very important to me.
I would like to add to Thomas' point. I saw an article about adversarial attack on text-like, and there was an article where an author described how to make adversarial attack and how to change prediction even with 1, 2, or 3 words. So it's really interesting because we can find and way some bad subpromise on model and find, I don't know, its weak places, and we can try in this way to fix them and make model better. So it's like to add some stuff.
May I ask a question, please, regarding tools?
Sure. Could you please introduce yourself in like one?
I'm Alexey Riznik. I'm actually not working in the area of machine learning, but I'm a software developer in different area. But my hobby is translation. So my question is there any tool that allows a human translator to interactively choose possible translation options for a translation, or even to modify some intermediate decisions made by the model, for example, the possible variants of part of speech tagging in a source sentence, and I mean some interactive GUI tool. Not because most models, they accept text as input and provide text as output, and if we talk about some human working with them, so it would be nice to have such tool. Are there such tools?
There are a few tools. I haven't heard about one for translation specifically. So usually these tools, they are demo made by people who have trained models. So for instance, Allen NLP has a tool to make the model generate word by word, and you can select one option. So you can say, okay, let's go in this direction. They have a nice demo on this. Can you show you how beam search or like greedy decoding work? We also have our own tool at Techniface called Write with Transformers that will show you like 3 possible completion. But both these tools, they are for completion. So they will take an English prompt usually and then let you complete the prompts. They are not for translation. But you would have to make it yourself, I think, if you want to do one from translation. I haven't seen anyone. Yeah. Parlay also has it's a Facebook library for dialogue chatbot, and they have something for human in the loop. There have been some research with human in the loop. So they have an interface as well, but this one is for chatbots. So you will rate the answer, say, oh, this answer is great, this answer is not great. Yeah, so that's the one I know. So not any specifically for translation, unfortunately.
Okay, thank you.
Thank you for the question. And Chad, maybe you could share your thoughts on like what tools or things are we missing, or like things being much more accessible, yet much more accessible.
Yeah. I think I'll answer this on like a much different time horizon, maybe. Like, I think what I'm really interested in, I mean, I think we'll have jobs in this space for a ridiculously long time. Like, this is like, as the technology gets more and more advanced, there's only more applications. But I think when you kind of step back and look at where we are with NLP, it's very clear that, you know, we're solving a number of very narrow tasks really well, and we're getting better and better at generalizing. Right now, today's models, at least in my opinion, like they're not very good at semantics. They're like huge areas of language that we're just kind of doing a pretty bad job at. And so I love that there's these digital assistants like Alexa and Google Home, and she's talking to me, and like they're making it so that everyone's interacting with NLP technology, not as a developer, but as a consumer. And I mean, it used to be that when you call into a phone support line or something like that and you get an automated voice, it's frustrating. Now people are like talking to their digital assistants every day. And so I think when you like, NLP is just part of a broader picture for these things. But when you get to the point where you can talk to one of these digital assistants and you can say, you know, teach me X or explain X, and then they understand your context, they understand like the actual world knowledge, like some semantics about what's happening, and they can kind of relate information to you in a way you can understand. I think that'll be I mean, like you can talk about like democratizing NLP in the sense of like having it so that developers can build experiences across a wide range of things. But I think today there's still a lot of experiences using NLP that are just not accessible. And I think when we get to the point where, you know, machines appear smarter and you know, we solve some of these fundamental language and knowledge challenges that that are kind of, you know, we've made a lot of progress toward, but we haven't really solved yet. I think that'll just like open the floodgates to where, you know, NLP is a daily part of everyone's lives. So I don't know, larger time scale, but that's like my biggest advance. I guess semantics would be the concise answer.
Thank you. I think that is a great conclusion for our today discussion. So I think we are like on time. So everybody can like return to their daily things that they are done. By the way, I'm currently in Kyiv. Vitalik, I think he's also in Kyiv. Thomas, where are you at? Sorry,
I'm in Paris today.
Oh, nice. And Chad?
San Francisco.
Oh, nice. So thank you very much once again, all the experts and all the viewers and all who gave us questions. I'm very excited to like make this thing today. So thank you once again, and good day, good night. Yeah, thank you all.
Thank you for the great discussion, guys. Thank you for joining us. Enjoy your day, evening, depends on your time zone. Yeah. Have a nice evening.